Considering its release by using NASA in 1977, Voyager 1 has been traveling via space for 45 years and has in the end reached the brink of our solar system. This has been lengthy expected, however, opposite to what scientists have continually believed. The space probe simply located something really sudden on the so referred to as fringe of our solar system, leaving all in sundry with more questions than solutions. What did Voyager 1 discover? Be part of us as we screened Voyager 1's impossible discovery. After 45 years in space during the Interstellar day trip, the Voyager probes hit a substantial milestone once they were given to the a part of space called the heliopause, which is the boundary keeping apart the solar effect from the big expanse of interstellar space. Now bear in thoughts that the exact role of this boundary had lengthy been a subject of discussion, but thank you to the projections of astronomer Bill Gurney in 1993, it becomes envisioned to lie among 116 and 177 astronomical gadgets, and each is equivalent to the gap between the Earth and the Sun. Gurney's estimations were proved to be in factor whilst Voyager 1 reached the heliopause approximately 2 decades later, detecting the expected upward thrust in plasma density. Here's where the exciting puzzle emerged. Notwithstanding the growth in plasma density determined by Voyager 1, there was no sizable alternate in the ambient magnetic subject direction. This was unexpected due to the fact a transition from an area wherein the magnetic field originated from the Sun to one in which it came from different stars have to have prompted an important shift. However, no such factor became witnessed. Scientists' probable notion Voyager 1 was the problem, but Voyager 2 similarly delivered any other layer of thriller to the puzzle whilst it reached the heliopause on the equal distance as its dual but failed to detect any magnetic subject modifications. These unexpected observations pose challenges to theoretical models depicting the behavior of the heliosphere and how it interacted with the interstellar surroundings. The prediction that there has been a synchronization between the heliosphere and the Sun's 11 to 12 months cycle did no longer align with the records gathered by the Voyager probes. Additionally, the solar wind, which fluctuates with the Sun cycle, changed into its most powerful while Voyager 2 arrived at the heliopause, suggesting that the anticipated role of the boundary ought to have been in addition out than 120. But it's now not all hopeless for the reason that information gathered by the Voyager probes has been instrumental in refining theoretical models. Due to the Voyager discovery, scientists now agree with that our Sun has moved from a warm ionized quarter to a partially ionized phase of the galaxy, probably induced via nearby supernova. Those exploding ancient stars heated the surrounding place and removed electrons from adjacent atoms. The boundary between these regions may be likened to a turbulent beach, characterized by way of combined magnetic fields and small-scale modifications close to the heliopause whilst negligible variations rise on large scales. As for what would become of the Voyager probes, their paths separated with Voyager 1 heading towards the constellation of Phoebus and Voyager 2 making its manner to the constellation of Cetus. At the same time as some scientists predict that the probes can have their mission in 2030, they could potentially bear for hundreds of thousands of years outlasting our species. Perhaps someday, they may encounter other star systems, carrying with them the golden record, a time capsule of humanity. However, the Voyagers failed to simply fly into outer space on their personal. They had been dispatched out with missions that had a lot to do with the future of humanity, exploring the deep depths of the cosmos. After America misplaced the robotic race to the moon towards the Soviet Union inside the 50s, the point of interest of area exploration experienced a shift. The moon and area dominance had been nevertheless notably appealing, so attention became toward a greater popular and well-funded manned application. At some point of that time, unmanned exploration became pushed to the historical past to tackle assisting function with missions like Ranger and Lunar Orbiter, paving the manner for future Apollo missions. But the concept of exploring other planets captured the creativeness of many, coming in second handiest to the pleasures surrounding the Apollo missions themselves. As a result, exploration programs naturally gravitated toward the subsequent step, exploring other planets. Looking back, some humans generally tend to overstate the medical significance of unmanned applications in comparison to the political and technological goals of manned flights. They argue that the robotic missions were more scientifically pure in layout and purpose, downplaying the scientific achievements of manned missions. But the reality is, the promise of shooting photographs of the planets became what absolutely captivated and ignited the ardor of the Yank public. The prospect of seeing those astonishing pics sparked the greatest interest and enthusiasm during the golden age of space flight. Magnetospheric physics and gravimetric research are indeed crucial, and their importance cannot be denied. However, it was the search for planetary snapshots that absolutely resonated with people. The dream started out to grow to be truth on September 5, 1977, when an extraordinary spacecraft became launched from Cape Canaveral, Florida, which is renowned for its checking out of missiles and space probes. This occasion marked the beginning of an high-quality journey as Voyager 1, a spacecraft, was launched into area. Apparently, Voyager 1 wasn't released first due to the fact just 15 days earlier, its twin, Voyager 2, had taken off on the identical cosmic adventure. Their mission changed into to explore Jupiter and Saturn, the gasoline giants of our solar gadget, together with their specific moons. What no one notion was that these intrepid explorers could surpass their preliminary dreams and mission to the farthest corners of the celestial horizon. The Voyager twins had been ready with cutting-edge technology, even by using the requirements of their time. From their engines to their propellers and antennas, everything became meticulously designed for durability. NASA got its thought from the Mariner spacecraft but brought some exciting modifications. The accomplishments of those Voyager probes had been nothing brief of spectacular. More than 40 years ago, their early observations of Jupiter and Saturn's moons left researchers surprised as they watched their preconceived notions about those distant worlds shatter before their very eyes. In advance, it was notioned that the overseas moons were desolate and percent-marked like our very own moon, but scientists belatedly discovered them to be teeming with geological pastime. Voyager 2 specifically accomplished several exceptional milestones during its journey. In 1986, it became the first spacecraft to skip by means of Uranus, and most effective 3 years later, it carried out a flyby of Neptune. Voyage 2 stands as the only spacecraft to have embarked on one of these courses to this present day. As those resilient spacecraft preserve their particular voyage, NASA has implemented measures to increase their operational lifespans. Over the past few years, non-essential components and heaters have been deactivated to preserve energy for the probes. This strategic move ensures that the Voyagers can continue functioning properly into the next decade, with the expected mission end date set for 2030. The result of the Voyager missions inspires bittersweet emotions for the scientists and engineers who've played crucial roles in this superb adventure since its inception. Their unwavering dedication and tireless efforts have carried the mission far beyond its initial expectations. The data transmitted by the Voyagers has yielded invaluable insights, propelling countless scientific discoveries and fueling the imaginations of researchers and space enthusiasts across generations. It's vital to observe that Voyager 1 and Voyager 2 were no longer your regular spacecraft. They were meticulously designed to be solid systems. Their rotation rate is more than 15 times slower than the hour hand of a clock. This planned layout choice minimized any blurring of images and records because the spacecraft zoomed through space. Scientists and the general public never ceased to be astonished by their amazing imaging talents. Even before their encounters with the outer planets, the spacecraft started out beaming back photographs of Jupiter while still numerous months far away from the planet. These early snapshots showcasing the swirling clouds and the well-known extraordinary red spot brought sheer satisfaction to the human beings at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that stole the show. Io is a little bigger than Earth's moon, but the exceptional element is that it turned out to have volcanic activity surpassing any other volcanic body in the entire solar system. The spacecraft detected some odd signals emanating from Io, and the bright snapshots they captured showed the findings. These snapshots revealed towering volcanic plumes and a surface marked by the ejection of volcanic material. One of Io's prominent volcanoes, Pele, has even erupted 30 instances better than Mount Everest, blanketing an area nearly as large as France. In total, the Voyager spacecraft snapped over 33,000 pics of Jupiter and its moons, revealing the planet's lovely beauty and the terrific range of the Jovian moonscapes. Before we dive into the latest mind-boggling discovery, let's not forget about the twin Voyagers uncovering breathtaking findings because their release. One of the maximum spectacular revelations turned into the lifestyles of Jupiter's jewelry, which although faint, added an extra layer of intrigue to the fuel massive. Voyager 2 unveiled the icy shell of Europa, one of Jupiter's 53 moons, believed to be over 60 miles thick. These findings challenged our preceding assumptions approximately these ways off celestial bodies and sparked further investigations into the habitability of icy moons. As the Voyagers bid farewell to Jupiter, they received a gravity assist that gave them an important boost, propelling them in the direction of Saturn. Without this nifty push, they would not have escaped the Sun's gravitational pull and ventured deeper into space. Voyager 1 and Voyager 2 then went their separate methods, each heading in the direction of new frontiers. Voyager 1 launched into a trajectory that added it close to Saturn's moon Titan, enveloped in an orange hazy environment. The mysteries surrounding this moon piqued the hobby of scientists, leading to extra studies on its complicated chemistry. Voyager 1 then veered northward, departing from the plane of the planets, and began its epic journey beyond the limits of our solar system. Meanwhile, Voyager 2 launched into a sequence of thrilling adventures that took it to the outermost planets of our cosmic neighborhood. In 1986, it made history with a flyby of Uranus, where it stumbled upon 10 previously unknown moons, increasing the planet's moon count number. 3 years later, Voyager 2 reaches Neptune, unveiling the first-rate capabilities of this distant ice massive. During its encounter with Neptune, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, making it the quickest wind ever determined on a planet within our solar system. As the spacecraft zoomed inside 2,180 miles of Neptune's azure methane ecosystem, it supplied unprecedented insights into this far-off international. Neptune's largest moon, Triton, turned out to be one of the chilliest spots in our solar system. The discoveries made by the Voyager probes have revolutionized our understanding of the outer planets and their moons, opening up new avenues for exploration and sparking excitement for future missions. Moving beyond Jupiter, the Voyagers ventured towards Saturn, where they discovered the complex ring system and the diverse moons orbiting the planet. Voyager 1 provided close-up images of Saturn's largest moon, Titan, revealing its dense, nitrogen-rich atmosphere and hydrocarbon lakes. Voyager 2 continued its journey towards Uranus and Neptune, becoming the first spacecraft to fly by these distant ice giants. The mission to Uranus uncovered previously unknown moons and unusual magnetic field interactions, while the encounter with Neptune yielded insights into its dynamic atmosphere and its moon Triton, with its geysers of nitrogen. Perhaps the most significant milestone of the Voyager missions was their crossing into interstellar space. Voyager 1 achieved this historic feat in 2012, becoming the first human-made object to enter the space between the stars. Voyager 2 followed suit in 2018, further expanding our understanding of the heliosphere and the boundary where our Sun's influence diminishes against the backdrop of the Milky Way galaxy. The data transmitted by the Voyager probes continues to shape our knowledge of the heliosphere, interstellar medium, and cosmic radiation environment. Their observations have challenged existing theories, provided new insights into planetary atmospheres, and sparked further exploration into the potential habitability of distant moons. Beyond their scientific contributions, the Voyager missions have inspired generations with their resilience, curiosity, and the spirit of exploration. The Golden Record, aboard both spacecraft, encapsulates the diversity and creativity of human civilization, serving as a message to any extraterrestrial intelligence that may encounter the probes in the distant future. Looking ahead, the Voyagers continue their silent journey through the vastness of space, carrying with them humanity's hopes and aspirations for discovery. As they traverse the darkness between the stars, their instruments continue to operate, sending back valuable data that will guide future missions and deepen our understanding of the universe. In conclusion, the Voyager missions represent a testament to human ingenuity, perseverance, and the insatiable quest for knowledge. They have not only expanded our cosmic perspective but also reminded us of the boundless possibilities that await us in the uncharted territories of space. As we celebrate their achievements, we look forward to the next frontier of space exploration, where new spacecraft will build upon the legacy of the Voyagers and continue to push the boundaries of human exploration farther into the cosmos.